Okay, this is the last part of this unit. We need to get to know the periodic table very well. There is a copy of this in your notes, and the first thing you need to do, and you should pause the video, but get some colored pencils and color all of these parts on the periodic table. So metals, nonmetals, you can use this as a guide. They're listed down here. So the pink and the orange and the yellow are metals, and noble gases are this, and nonmetals are this corner right here. The metalloids are the yellow ones going in between here, which this is going to be kind of hard, but the periodic table that I gave you should have all of this labeled. I want you to actually color it on the periodic table in your note pack. It will help you remember while you're coloring. As you're going over the metal section, you should be saying in your head, these are metals, these are metals, these are metals. So repeating that in your head while you're coloring it is the point of a coloring activity. If you want to be super fancy, you can say all of this stuff out loud as you're coloring it, and I promise you it's going to help you remember. So the periodic table is organized into horizontal rows. Those are called periods, and that is how many orbitals are circling around the nucleus. So remember, electrons are flying around the nucleus. They're in kind of a pattern. They do fly around like wild, crazy people, but there is a little bit of rhyme and reason to it. So the first orbital is right here. Here's a second orbital. Here's a third orbital. So if an atom has 3 orbitals, it's going to be in the third horizontal row of the periodic table. Pay attention to how many electrons are in each orbital. So there are 2 electrons in the first orbital. After that, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons here. There are 8 electrons in this orbital. Every orbital from there on out has 8. So the first orbital has 2. The other electrons have 8 orbitals, and that is going to be super important. How do you know what atom it is? You can count up all of the electrons. So there's 2 plus 8 plus 8 more is 18. So whatever is number 18, which is argon. Vertical columns are called groups or families, and they're grouped that way because they react the same way. So just like your groups of friends or the people in your family share similar traits, families and groups on the periodic table share similar reactivity properties. If you remember, I said electrons are what are the part of the atom that's going to do the reacting. The only electrons that can react are the ones in the outer shell. We'll watch these videos in class, but if you look back at this picture, everything in these inner shells is stable. The only electrons in the outer, or the only electrons that can do anything are the ones that are on the very outer edge of the atom. So really the only electrons we care about are in this outer shell. So it's important to know how many shells there are, therefore the period, and then we need to know how many electrons are in that outer shell. And that matches the number on the periodic table. So this is explaining why electrons are important. 8 is going to be our magic number. We'll talk a lot about that. Hydrogen and helium only need 2 electrons because they are in that first horizontal row. And remember that first orbital can only hold 2. So that orbital is stable with 2. All the other orbitals are stable with 8 electrons. So for the most part, 8 is our happy number that atoms want to reach. We call it a magic number. So magic number 8, happy number, however you want to think of it. So the family number matches how many electrons are in that outer shell. So valence number matches group number, and we're going to look at that. So we need to name some of these groups. Group 1A, so the first vertical column, are called the alkali metals. They have 1 electron in their outer shell. The second vertical column going down has 2 electrons in its outer shell. Those are the alkaline earth metals. Then we're going to skip that part of the table that's down low and jump right over to group 3A, 4A, 5A, 6A. Finally, 7A gets a fancy name called halogens. And group 8 are the noble gases. Group 8 has 8 electrons in their outer shell. They are called noble gases because they are super fancy. They think they're better than everybody else. They think they're nobility, and they don't react with anyone. They already have a full outer shell. So transition metals are that down low part in the middle. They're called transition metals because we never really know how many valence electrons they have. And that will make sense in a little bit, but right now just know that we don't know. So let's review this really quickly. Find chlorine on your periodic table. It is in group 7A. That means it has 7 valence electrons. So see if you can figure out the rest of those, pause the video, and then check your work. While you are working this reactivity, so these family groups is one of the ways the table is set up. So electron orbitals going across, and how many valence electrons is how we organize it up and down. The most reactive atom on the periodic table is francium. The least reactive atom is helium. So we kind of go in a diagonal, most reactive down here, least reactive up there, and everybody else kind of follows a trend. All right, see if you can do all of this. Find nitrogen on your periodic table, what period, what group, find the atomic number, mass, blah, blah, blah. See if you can do that. And I thought I had the key up here. So nitrogen is in period 2. So it has 2 orbitals. It is in group 5A. The atomic number is 7. The atomic mass is 14.007. If I round that atomic mass, I get the mass number, and that will be 14. Number of protons is 7, so electrons is 7, and since the mass number is 14, there are 7 neutrons. The valence number, how many valence electrons, matches the group. It's in group 5, so 5 electrons are in the outer shell of nitrogen. I'm going to skip this. Schrodinger's cat is pretty cool. We can talk about it in class. But the next thing we're going to talk about is electron configuration, which I will do in a separate video.